Good evening, everybody. Thank you. Tonight we're going to talk a lot about weather, of course. I'm Ryan Boudreau. This is Cory Gates, meteorologist Cory Gates, who, if you remember, you read a lot of good stuff from us, and you actually learn weather, and that's what we're all about. And having a local meteorologist here that knows what's going on, it's unbelievable. So if you are a member, thank you. And at the end of this, you'll probably become a member. Cory Gates, University of Wisconsin. This guy received the highest honor you could ever get in the National Weather Service. They don't give out those awards too much at all. Cory, what else I can say about you? A gentleman from the South. A gentleman, a true gentleman. And he hates when he's wrong. He hates when he's wrong. And he's taught me a ton about weather. My background, I've done live TV for years over at Plum TV. Now they went down the drain. And we have a new local TV station coming. Andy, what's it called? Aspen 82? Yeah. Aspen 82 coming. And I'm going to do weather for them. And we're just going to dial you in. And we have a lot of good news on the way. We have a pattern change. Yay. Let's give it to Let's give it to Cory Gates. Cory, take it away, buddy.
It's coming. Any of you members, you gotta be.
What's a
Keep
member?
raising. I need some more hands. You will be by the time I'm done. All right. What we're gonna do, guys, is we're just gonna talk about the weather. I'm gonna tell you how we do it and get it right versus many people who don't. But you know, that's just life. We get it right, and I'm gonna show you what the models look like, how they're derived really fast. It's not going to be boring. And then we're going to talk about why it's been dry for 21 days and why that's hideous weather we've had and why it's going to change. And it's going to change significantly. Like by next Monday, wonderful. Cows coming, cold. And I'll show you why. And I'll show you why the models are right. And I'll tell you why on the site. 18 days ago, I told everybody, and Susan will tell you, yes, this was coming many days ago. We can do this weeks in advance, all right? So let's start with the models in general. There's a ton of models. The models are done by the government. The government sponsors or pays for all the upper air sites in this country, in Canada, Russia, Navy ships, airplanes, everything. Data comes from all these entities all across the northern hemisphere, and it's put into one big supercomputer. The fastest computer in the world, by far, no arguments with anybody, is the Weather Service computer in Suitland, Maryland. It does 2 billion calculations per second. Stunning, incredible power. So let me just show you where it comes from, and then I'll show you what the models look like, and Ryan and I will talk about a few things back and forth. I need a little laser thing. This is the upper air sites in the United States. Okay, if you just take a glimpse at that, notice how far apart each site is. Here's Junction, here's Denver, then there's down New Mexico, Phoenix, Vegas, etc., etc. So there's distance between each site. Between Junction and Denver is many, many miles. It's unfathomable to calculate what air parcels are doing just in the distance between Junction and Denver. So that's why it's never going to, people always ask, well, how come you can't get it right every single day? Generally we do, because we're lucky, but not lucky because we're good. But that's the reason it's not a perfect science, because if I had a star every 20 miles away, the data network would be so dense, it would be incredible, and seriously, it would be very hard to be wrong. But the government can't pay for a star every 20 miles away, because it costs $150 a pop to send the upper air balloon up, and we do it twice a day. So imagine if the data network was super close together, it'd be millions of dollars just for a day. So they're separated. So it's not perfect, but I just wanted to let you know that. Aside from the United States, if you can just envision more stars, the same thing happens across Canada. The same thing happens across Mexico. The same thing happens in Russia, China, all across Europe, you know, the Alps, Germany, you know, all that, the whole northern hemisphere does upper air balloons at the same time twice a day. In Colorado, the time that the Weather Service is done in it's called Universal Coordinated Time, or Z time. But in our time here, it's 5 a.m. and 5 p.m. Balloons go up twice a day, all around the world, okay? So what comes from those balloons is this. And this is actually real time. So GJT is Grand Junction. That's the upper air sounding right now that came out of Junction when the balloon went up at 5 o'clock, okay? Long story really short. The red line is temperature. The green line is dew point. Dew point's a hard term to explain, so I'm not gonna. The green line is just moisture. Don't get caught up in the relative humidity term, because relative humidity is just useless. In the Weather Service, in the government, everybody that knows weather, we use dew point. So essentially, the closer these lines are together, temperature, dew point, the higher the humidity is. So when they let the balloon go at Junction, it was 50 degrees. So Aspen's elevation, or 10,000 feet, is right about here at what's called 700 millibars. Don't worry about stupid terms. But it's already 28 degrees. So as you go up in altitude, it gets colder aloft. See where the lines get closer together? Higher up, that means there's a little bit more relative humidity, or it's more humid. You see the high clouds that came over this evening? Remember how kind of thick they were in the evening? That's an indication of why they were there. But the mid-levels, see the difference? The farthest, they're far apart, the red and the green in there. This is the mid-levels of the atmosphere, like 10,000 feet above our heads. It was dry. You didn't see any mid-clouds, so we just had cirrus this evening. But the moral of the whole story is all these stars have the same thing. They all look the same. See, there's wind directions at all levels. So all this data goes into one big, huge supercomputer like this in sounding form. And then the models produce guidance, okay? So I'm going to show you what the guidance looks like. And then we'll start talking about what's going to change, et cetera, make y'all happy. Now, if you've never seen this before, and I've done these talks just a zillion times, and I call it Egyptian hieroglyphics, because it's very, very confusing. This is, the weather's done in pieces of the atmosphere, how you diagnose the weather from up, all weather starts from up high and works its way down to the ground. So so we look at different slices of the atmosphere. So this is at 5 p.m. this evening, this map, okay? Long story short, this is at 18,000 feet or 10,000 feet above Aspen's head. This is what the weather looks like and how we determine it. These black lines, the wind basically just, when you're up at 10,000 feet, there's no friction. There's no mountains, there's no trees, there's no nothing. So the wind blows parallel to these lines. When you guys read my stuff in the morning, and you will eventually by the time this is over, these are called, when I use the term like upper level disturbances, I don't say vorticity because it's too confusing, but that's what those colors are. Those upper level disturbances are what cause weather. The brighter the color, the stronger the impulse in the upper atmosphere is. So when I'm doing a forecast, we're looking for how these travel, okay? So let's do this. I wonder if this will do it. Let's see if it does.
There you go.
Yeah.
There you go.
Okay. So let's just start with a current. Shoot, I can't get the whole screen on there. But let's just start with this is basically a loop of 24 hours, okay? Let's familiarize your background. Aspen's right there where my thumb is. Here's the state of Colorado, you know, Utah, New Mexico, Arizona. Aspen's right there, okay? So essentially, this is actually a good map. This is exactly what it's looked like for the last 21 days. I almost said a cuss word. There's just been a big high. See, can you all see the Aleutians up there at the top? Y'all are pretty good at geography, right? Like up in Alaska, see the big upper level low that's just spinning? Well, the configuration of the pattern has been that upper level low has sat there for 21 days straight. Today we got lucky with a dusting or an inch, you know, here at the school in town, 1 to 2 inches at the resorts. But since October, you've noticed we get one little small event, and then we have to wait 2 weeks. This time we had to wait 3 weeks for the next one. And the reason why is that upper level low has been really stable. Now remember where Colorado is. You all don't know this because you're not used to looking at it, but there's nothing going on here. You don't see any yellows, do you? There's nothing. All the yellows are staying up in Vancouver. They're staying by Valdez. And up in the northeast, see that yellow blob approaching the northeast? Those are what cause weather. Now, so basically, this is actually a ridge. See the difference between a ridge and a trough? This is actually a ridge of high pressure. So this is telling you what it's going to look like tomorrow morning at 5 in the morning, that very last frame. And it's dead. It's dry. That's what a ridge of high pressure is. So if I stop this, this is at 11 in the morning. Let's just do a quick forecast scenario really fast to show you how it's done. See this? Remember, we're here. This is just a big, stable ridge. You just have a little blip here, a little blip there, a little blip there. I think it's pretty obvious. You see how all the jet, these yellow things are associated with where the jet is? It's all to our north, and that's how it has been. So tomorrow, when I'm looking at the weather, and I see this, I'm not going to forecast snow tomorrow. Maybe some moron does, but we're not. That's just nice and dry. We have forecast soundings. Remember the first sounding that came up? It'll show you what the models think the atmosphere is going to look like through. Let me just show you really fast, and then we'll get to the good stuff. See, there's just a ton of science that you can do. Like I'm taking what the model thinks the sounding's going to look like tomorrow morning. There we go. So remember, this is like tomorrow at 11 o'clock. Remember how there was the big ridge? Now, remember when I first started out, you had the red and the dash, or the other line? That's where, the closer they are, the more, the more weather there is, because there's more humidity, et cetera, et cetera. But see, these lines are spread apart. So the only reason I'm showing you this is the capability of the models is incredible. So basically, this is a forecast sounding for 11 a.m. tomorrow morning. So when I'm sitting at home at the desk for hours on end, when it's gonna snow, I'm looking at what the atmosphere looks like in sounding form. Are the lines close together? Is there instability? How much precipitable water there is? All this stuff you can tell from these forecast soundings, and it's critical to look at these every day and correlate it with that map. So tomorrow morning you saw the flat ridge over us. That's nothing to speak of. Then you see the sounding. The lines are far apart. That's a stable sounding. The atmosphere, it cools a little bit here, then it's actually what's called isothermal as you go up. The temperature doesn't drop very much. It's stable. Nothing's going to happen tomorrow. Tomorrow when you're eating lunch at 11 o'clock, you're going to think of idiot Cory. Oh, there's no weather. He showed me last night. The forecast soundings have that. And that's what we do every day. So let's let me go. Let's show everybody the change because it happens.
We like change.
Because time's going to run out quicker than I think.
So in this next graph, everybody, we're going to show you change. And it's not Obama. You'll see in the northern Aleutians in Greenland, Cory's going to show you that ridge has finally broke down, and that's a game changer. That's totally a game changer. And on this map, you'll be able to see how this happens. And Cory, you could get this baby. We could get this thing flowing if you hit the time lapse, right?
I will. Yeah. In 1 second, I will. All right. So let's just go and get to the good stuff right away. This is what first of all, let's orient yourself. United States, Colorado by that 12, I'm not tall enough. Out here is the date line, 180 degrees. This is way out in the Pacific Ocean. This is a perfect example of what it's looked like for the last 21 days. There's a big high right at the date line. See where the lines extend upward? That's been very, very stable. And when this extends upward like this, and the jet just comes around and it curves up this way, and it can't progress east. So it's making a big turn, and remember the big low that we were talking about off Alaska? Well, there it sits. And that's exactly what's happened for the last 21 days. But now, the models are sensing the change.
Should I go forward? Go forward.
You have to hit, yeah, you got to hit those things.
Oh, shit. Just zoom in.
Or just hit normal, and it'll go back to the regular. Here, let's do it. Let's loop it really fast.
Yeah, that's the best way to do it.
And we'll show the loop. And I think, first of all, there's no way I can explain to you, the true weather in 50 minutes. So I'm going to just focus on how this pattern's going to change and how we're going to have way more snow, way more frequency of snow, and things look a lot better. It's not going to be one of those hideous winters where we don't have anything.
So you can see the big ridge.
It just takes a second to load, 384 hours.
And then watch that sucker break down. Boom.
Yes, comments. I like that. You guys are savvy.
And that's huge. I mean,
Yeah, this has a long ways to go. It'll just take a second.
So we haven't seen that change.
What caused the illusion?
What caused it to break down is the big upper air high that's been near the date line. It gets completely eroded, and you'll see in the future that there's a big upper level low, right where my hand is and extend upward. It gets in that spot over the next week, and the big upper level low just changes the whole entire pattern because it's been a big upper level high for 3 weeks. Or really since October, really, because we haven't had that much happen.
There we go.
it just breaks right off.
It's getting ready. It's almost done loading them.
And then he'll talk about the 140. Which
Yeah, very good.
140 they had. 140's a good
140 should be, I say this all the time on the website, 140 should be everybody's favorite number in Colorado. And I'll tell you why in 1 second. Okay, God, I need a pointer. Now, it's almost done.
So, there we go.
You
Nice.
see where there's the big upper high in the beginning? Now watch it just get eroded. And 140 west is right here. See where this new big ridge pops up and stays right here at 140? Just watch that line. 140 west is the key to the whole world here. Because usually when there's a ridge at 140, the downstream trough is over the Rockies. And you'll see that happen. Okay, now let's do this super fast. Here's current. The big stupid high along the date line is holding that big upper level low right there off the Aleutians. Okay, so let's go a week, or I'll just step through it. 72 hours from now, there's some weakening. This big upper level high, see it? It's not the same anymore, and it's just kind of just dissipated. Now, see the beginnings of the ridge right here? Well, what's going to happen is this ridge is going to progress downstream right here to everybody's favorite number, 140. And watch when you get a ridge at 140, anything that's to the north of the ridge amplifies southeast, and it creates a trough in the Rockies. And the models have been super consistent about this over the last 10 days happening, which is really good. So here's
Saturday.
Here's Saturday. Oops.
Just paying attention. I like it.
Here's Saturday at 11 a.m. See? 140. Favorite number. Big upper level high. Here's the date line. See, now there's a big low. It's been replaced by a big low, so the circulation around this big low is causing the big high at 140, and this is going to end up being a very stable entity, which is good. Now remember I told you about the colors? See these colors? This is vorticity, or upward motion. Big ridge here, all this energy is going to start sliding southeast. And it's already doing it, but this is by 11 a.m. Saturday.
And another thing too, west wind is the best wind for Aspen.
By far.
That you can't go wrong.
And here's 11
We
a.m.
always get our big dumps on a west wind.
Sunday.
Southwest, the worst.
Look at that. That's heaven on earth, my friend. That is heaven.
Look at where this sucker is.
Look at the big ridge at 140. Aspen's right here at my finger. And the good news is, and I'll say it this way, when you join the site, I talk about this a lot. You can ask anybody that they're just mesmerized by the whole thing, I have to be honest. But I talk about these, we have a bunch of different models. There's a Canadian global model, there's a European model, there's the United Kingdom model, and there's our American models. But the long story very short, they're all showing this big ridge coming up at 140 and this upper level energy dropping over Colorado. If this were to verify perfectly, it might not, but it's going to be in the ballpark. That's fantastic. It's dumping Saturday night into Sunday. Probably only like 24 degrees Sunday, and it's a drier snow. So in my forecast, basically the models tell you what's going to happen in the future. It's just whether you believe them or not. And there's a lot of process to go through to determine if they're going to be right. So a long story short, that's what an upper level pattern looks like when it's going to snow in Colorado. Again, Colorado's just above that X. Okay, so that's Sunday. That's great news. Let's look at Monday at 11 o'clock. Just that down arrow. This one here will do it.
Good.
So see, in theory, this is in theory, the X was here. So by Monday at 11 o'clock, that's passed on to the east. But the key to life, the key to this pattern change is look right here. 140, big, strong, perfect ridge out here at the date line. You don't see any more big highs. You see this big jet coming off the Sea of Japan, and it's flowing around this big ridge. So you look upstream, look, already across Washington, Oregon, Idaho, another blob of jet stream energy is already diving southeast. So it's going to do it again
Tuesday.
Maybe not quite as much, but it's going to do it. This is a perfect pattern to get snow, is the ridge at 140 west. And this is generally what all the models are showing. Now remember this piece? This was here before. Oh boy. So it's traveled southeast and underneath us, and we got more orange or yellow. Now look, there's another one. So if you look, ridge at, I get excited. Ridge at 140. You see all this? Where's that going to go? You already know where it's going to go because the ridge is here.
And you remember
it's going to come southeast.
I gotta say it, Cory.
This is exactly what it did in 2007.
Remember
2000. I didn't want you to say it because I didn't want to promise that.
Come on.
But this is what it did in 2007,
This was the
2008.
same setup in 07.
We were dry for 27 straight days in November. Worse than now. And then this set up, and remember December of 2007?
Game time.
It snowed for 27 out of 31 days, and it was hideous.
Below or awesome.
But you're saying it's not that, right?
I don't think it'll be quite as good as that, but we have potential for a few feet in the next few weeks. And I think that's very realistic. So see, here it is again. Here it is again. Just look at the stability. Big jet, no high anymore. Your favorite number, which is? 140. God, love you guys. See, we're still in this northwest flow. This little piece that was up here weakens a little bit, and now it's down here. But keep watching this as I keep going through.
And that's by like the 20th of December, right, Cory? We up around that month far?
Not far, not quite this.
That yet?
This next screen is 10 days out. This is next Thursday. So see, there's a little bit of a lull. At least the models think so. But we're still in this northwest flow off. This is still here, but watch these guys. They're going to come up, over the ridge, and down. And that's just what you want to have happen all the time here. And I wouldn't be all excited if all the other models weren't showing the same thing. See, when you have consistency, that's good. Here they are. Doink, doink. That one's going to go like this. This one's going to come down and go like that. I mean, this is all in theory now. We're talking 12 days away, but when you're trying to forecast a big, oh, I had a breath. When you're trying to forecast a big pattern change, the key is trends. It's not exactly what's going to happen on day 11. It's what it's the trend of what it's doing across the whole hemisphere. My God, that's perfect. Look. Look, here's 140. Look, this blob of yellow is incredible. That's digging down. Here's color. This booger is going to come down like that. It's going to do it again. So if this stays like this, we're in great shape. In theory, this was valid next Sunday.
So can we plan your powder day in advance, like a little slogan?
We can.
Yes, we can. We can do it.
And we
sometimes
do.
12 to 15 days in advance. So if you
Look,
got to get a day off. Or whatever.
again, it's heaven. Look, it stays. 140. This one is that blob that was up here. That passes us. Oh my God, here we go. So this could be a really good month. It could go from total, you know what I mean, to really, really good. So that's what I kind of been telling people, but I haven't guaranteed mega dumps. But
Cory's been keeping it to himself because he's afraid to call me because he knows I'm going to go.
because
crazy.
he'll babble it on Twitter.
And
for
I
weeks.
see all this stuff, but obviously he's way more
See?
educated than I am.
Look at this.
He's,
It's still perfect. Here's 145. It's still sitting there. So the flow around it, more yellow's coming. This really, and I know it's only a model, and models have to be taken with a grain of salt. This is 384 hours out, 16 days. But what you saw here from starting this Saturday, which is 144 hours, through 384 hours, so 6 days through from day 6 through day 16, it looks pretty active. And there's a thing called the ensembles, which takes a model run like this, but it does 20 of them. It does 20 model runs off the upper air data. This is to keep, the reason they do this is because if you take 20 model runs and then take the mean or the average, it tends to take out the extreme or outlier solutions, where this is just one model run off one piece of data, you know. But the ensembles take that same piece of data and they run 20. Moral of the story is the ensembles, basically, the mean across the northern hemisphere for this same time period show the same thing. The big ridge at 140, the big trough develops generally right over us. So the long range looks fantastic. It really does. And I'm glad to say it. Now, you can't say I walked out. You can't say you came in as Cory promised 5 feet of snow, because I'm not going to promise that. But I am going to promise much, much, much better weather. It'll be colder, more frequent storms. They may not all be big. You know, one may be 10, but then 3 days later we get a 5. Then 3 days later we get an 8. Then 4 days later we get a 2. Compared to what we've had, that's like heaven on earth. You know what I mean? And these models are good at giving you trends like that. I can't give you the details on day 14, but I can give you a trend. If somebody wanted to fly, somebody calls Ryan and says, I'm coming out from New York, I'm taking my private jet.
All the time.
They meet him at the airport. It happens every day. Do you have a trend for what's going to happen? We tell him, yes, he pays me a ton, and we're good. So that's the general. This is what, now I didn't really cover anything of what the models can really do. There's stuff like upper level divergence, and it's just amazing, hideous math. But I just wanted to hit this. Now, let me call up the statistics thing, and you can tell them about
Yeah, I'm gonna let you kind of roll on that, but I'm gonna bring it in, so you know.
So we're happy, right?
Everybody's a little happy here.
I think we're going to be right. These trends are correct, because remember the ensembles I was just telling you about? If those 20 model runs, the mean, they oftentimes don't agree with that one that's called a deterministic run, just what I just showed you. It's just one model run off 5 p.m. data. The ensembles take that same 5 p.m. data, but do 20 runs. If the ensembles, a lot of times the ensembles won't match what that looks like because the one run is too extreme. But in this case, the ensembles match what that deterministic run just did, that general big ridge at 140 trough over the Rockies-ish between here and Wyoming, which is fine for us. So it has a correlation between the 20 other model runs that it's probably going to happen.
So this next segment we're going to go into is, where do you go for weather? Now, if you don't go to our site, what do you do? AccuWeather or weather.com
Oh
or
my God, I feel so sorry for you.
theweatherchannel.com or whatever these, and then there's a underground, I think they use. underground, total crap.
Here's how it's, we're going to show you
I mean,
how
we're going to show you why it's crap. A lot of people, I mean, it's like, they're like, I see snow on my iPhone. I'm like, and I'm sitting next to him, and I'm like, I don't even want to say anything to this guy. I know it's going to happen, you know, whatever. But we just want to, you know, intelligently let you know, why you don't go to those websites. I don't even know why they're there. But they are, you know.
Let me explain this.
Explain this.
You remember all the upper air data? It goes into one big supercomputer. For every airport in the United States, and every co-op station in the United States, which means John Smith, who keeps obs 1 mile southwest of Aspen for 20 years and he's consistent, he'll have this statistical data. So at the very top left, KASE, that's Aspen, Sardi, pick and field, that's the airport. This is what the model produces statistically to give us an idea of temperatures. This is current data. So for tonight, see where it says cloud and then scattered, few, clear, that's what those symbols mean. It's forecasting a low of 13. That's all well and good. That's fantastic. That gives me at least a ballpark figure to start the day, the forecast process of what the low might be tonight. It's saying tomorrow, Tuesday, see where the 47 is? It's saying a high of 47 at the airport, broken clouds, which means it's not totally sunny, blah, 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 blah. The next night, Tuesday night, 22, Wednesday, 54, Wednesday night, 30. But what Ryan's talking about, the weather underground, the AccuWeathers, the idiots, sorry. A lot of them aren't looking at those maps that I just showed you. There's programs out there that take this statistical data, very easily do it. So the program says, it sees broken. So the program writes partly cloudy for tomorrow. It looks at the high temperature and a high of 47. It looks at the P12, means probability of precipitation, only 1%. So tomorrow that computer might be right on the dot from this statistical data. Partly cloudy, high 47. It sees 0 chance precipitation, so it doesn't say any snow. Okay? So the statistical guidance is right for the weather undergrounds. His forecast will look similar to mine.
But there's no
I'll let you do
human influence.
There's no human influence.
And that's a big thing.
So down the road, here's a perfect example. Here's Saturday, here's Sunday, and here's Monday. Look at this hideousness. So we just looked at the model, right? So we know the weekend what it's going to be like. It's going downhill. It's going to snow. I pretty much tell you that. It's going to happen. But the statistical model, when it starts to get to day 5, 6, 7, 8, it trends toward what's called climo, or climatology, what has happened in the past on December 8th. And that influences it. But the weather undergrounds and all that, they don't care about that. They don't have time to go do a day 7 in Aspen with emphasis on what's really going to happen. All they do is they have the computer program write the forecast based on this statistical guidance. So Saturday, it's got a high of 44 with only an 18% pop, which is out to lunch because Saturday night it's going to start, and maybe even during the day. So Weather Underground is going to say partly cloudy Saturday with a 20% chance of snow. That's why you see this mess in the extended. It's coming from this. Not coming from me. It's coming from this. So Sunday, it's going to say a high of 32 and only a 48% chance of snow. Remember, they're just taking it off the computer program. That's a travesty. It's going to be 100% by Saturday night. It's going to be 100% on Sunday. I don't do that either. But can you see why it's messed up? Because all they're doing is the computer program is just grabbing those numbers on top, grabbing those pops here, and snow 0, 0, 0, 0, 0. It's just, ugh. I just wouldn't even look at it if I were you. But I can't tell you to join, but I would.
Let's want to end it and talk about the website and kind of what were new things that are coming.
Guys,
I know it gets late so fast.
Yeah, I know we're pretty much wrapping this up, but
guys,
I want to invite you to come to AspenWeather.net, check us out. It's a small fee, $40 for the winter, one-time fee.
Very detailed for us.
And
for us.
you can email us as a member and get a forecast tailored to your outdoor adventure. We don't care if you're going up to 14,000 feet. We have a weather forecast for you, wherever you're going. Cory's got it. And then when, in the summertime, if you're going on hiking, biking trips, anywhere, you know, Moab, you want to know how to dress for 3-4 days as far as a thunderstorm forecast. We've got the answer for you. We're going to upgrade our website in the next 2 weeks. Hopefully by the 14th, we'll have our new website. We have a new webcam live that'll be streaming somewhere in Aspen. We don't tell anybody where it's going to be. Looking at Aspen Mountain, and we have one.
Only one.
Yeah, it's better than any of the Ski-Co ones. And then we have one at the airport that me and Cory own. It's ridiculous. You can see planes come in all the time, and wherever you are in the country, if you're here and there, and you want to know what's going on in Aspen, just go to the live streaming HD webcam, and you can see what's going on.
Help you. The Waltons do. The Walmart owners. Rob
We deal with
does. Michelle Obama.
Michelle Obama's a big fan.
Every single thing for her when she came to Aspen because they know me from the guts. I can help you.
Cory's got it down. We help out a lot of people in this valley, and we really, really appreciate your support. I'm really happy that we actually sat down and said, man, we got to really do this, Cory. We were taking kind of a chance on the whole, you know, charging money, but advertising's not.
Membership.
It's tough to advertise in Aspen and get people to say, hey, I want to give you money for weather, you know. So, but it's working out, guys, and I really invite you to go on site. And if you are a member, we'll help you out. Just email us, and we'll tailor our weather forecasts to your outdoor adventure. Thanks a lot, everybody.